Hello friends, welcome to Shiksharthi. In this video, we shall solve question number 9 to 11 of exercise 8.1 on trigonometry. So let's start. So question number 9 says in a triangle ABC, the right angle is at B, and if tan A, the value of tan A is given to you as 1 by root 3, then find the value of these two expressions that they have given to you. So now there are two ways of doing this question. One is the basic way, the other is the best way. Now the best way is the time saving way, and the basic way is wherein you write each and every step. So what we are doing here is, first we'll be discussing the basic way, and if the time permits, then we'll be talking about the best way as well. Okay, so we know that tan A is equal to 1 by root 3. Can we, the first thing, as we have been talking about in other videos as well, as far as the question solving is concerned, let us first plot this information. So plotting this information is, let us draw a triangle wherein the right angle is mentioned, that it is given as angle B. Okay, so now this is a ratio. So even before, after I have plotted this piece of information which says that tan A is equal to perpendicular upon base, so the value of the perpendicular here is 1x, the value of the base here is x root 3, right, and hypotenuse we can find out the value. Okay, now this is the basic way in which you are supposed to attempt. Okay, having said this, now can we find out the value of the hypotenuse here? Yes, but before we begin, the first thought that you need to give here is, now tan A is positive, right? This tan A is positive in which quadrants? The first quadrant and the third quadrant. That means your focus will be basically on the first and the third quadrant. And as discussed earlier also, whenever I am using Roman numerals, that means I am talking about the quadrant. First quadrant, second quadrant, third quadrant, fourth quadrant. Okay, so now the hypotenuse, the square of the hypotenuse is basically what? The square of the perpendicular plus the square of the base, which means this becomes x square plus 3x square, which is just like saying 4x square. So the value of the hypotenuse square is 4x square. So the value of the hypotenuse here becomes what? Either plus 2x or minus 2x. Is it mentioned in the question that A is an acute angle? Or is it given that which direction are you supposed to take? Here I have taken the acute angle direction. That means here I am talking about the first quadrant. Though I should have made two triangles. And which is the other triangle that I should have made here? The other triangle that I should have made here is just kind of, like this. So wherein, let's say this is C, this is B, and this is A. In that case, the angle here is this. The rest of the values, they remain the same, except for the fact that here this is plus 2x. In this case, this becomes minus 2x. This is 1x. This is x root 3, and this is 1x. Okay, but anyway, so we got the value of the hypotenuse. Now can we substitute these values here? For example, how much? So at a time we'll take only one case. So let us say first we are talking about the first quadrant only. So we'll take up the basic values in which we know that in the first quadrant all the trigonometric ratios are positive. For example, how much is sine A here? Let me first write down the PBH concept here. So sine A is perpendicular upon hypotenuse multiplied by cos C. Cos C is base upon hypotenuse plus cos A base upon hypotenuse into sin C perpendicular. For sin C, this becomes the perpendicular upon the hypotenuse, and then we can always substitute the values. So if we substitute the value here, how much is P by H? 1 by 2 into P by H, which is again 1 by 2, plus B by H, which is root 3 by 2, into root 3 by 2. So we get this value as, this is 1 by 4, and root 3 into root 3 is 3, which is equal to 1. This is the basic way of solving it. Having said this, what is the best way? Now you already know the trigonometric ratios. So for example, you know that cos theta is equal to sin 90 minus theta. We have already done it in our videos, right? So can we use this PBH concept? Yes. So if A plus C is equal to 90 degrees, so what are we saying basically? If A plus C is equal to 90 degrees, thing also in this question, in that case this value becomes redundant. I don't require this at all, and I could have solved this with I could have solved this without this. And what would have I done? I would have just taken the values. How much is sin A? Sin A I know is cos C. So this cos C into cos C, I could have written it as cos square C, right? And here cos A can be written as sin C. So this essentially gets converted into cos square C plus sin square C, and I can use this trigonometric identity equal to a 1. I hope you understood. So that is the best way. So had it been an objective question, you could have done it orally. But when it comes to a subjective question, either I do it like this, or I could have just substituted the values, is what we have done basically. Now in this case, let us first do it by the basic way. How much is the value of cos A? So we know it is base by hypotenuse into cos C. We can just borrow the values from here, which is P by H minus sin A. How much is sin A? Is again P by H. How much is sin C? Sin C is B by H. Now if I see here itself, I can say that the value is equal to a 0 without even substituting the values. So for this question also, I don't require this. This is redundant. But since they have given it to you, you can just check your answer. Now, do you know the value of B by H? Yes, B by H is root 3 by 2. P by H is 1 by 2. Minus P by H is again 1 by 2 into B by H, which is root 3 by 2. So which is just like saying root 3 by 2 minus root 3 by 2 is equal to how much? 0. Hope you understood this, right? Let's move on to the next question, which is question number 10. So in question number 10, they have given that in the triangle PQR, the right angle is at Q, and then they have given the sum of the line segments PR plus QR is equal to 25 centimeters, and then PQ is given to us 5 centimeters, and they have asked you to determine the values of these three trigonometric ratios. So the very first thing that we'll do here is we will plot this with the help of a triangle. Given that right angle is at Q, right? PQ plus QR, now PQ, which is the value of the perpendicular, is given to you as 5 centimeter. The value of the hypotenuse is not given, and so the value of the base is not given. So what they have said here is B plus H is equal to a 25 centimeter. And then they have given you the value of P as 5 centimeters. Now using Pythagoras theorem, we can say that H square is equal to P square plus B square. Right? Now, can I say that B square is nothing but, can I write it like H square minus B square? Which is just like saying H minus B into H plus B, as we have done in earlier questions also. Now how much is P square? 25. Now what is the value of H plus B? H plus B. So the value of H plus B is also 25 into H minus B. So from here you get the value of H minus B as 1 centimeter. Now you have two simultaneous equations. One is H plus B is equal to 25 centimeters and H minus B is equal to 1 centimeter. So when I add these two equations, so let's say this equation and the equation that I have underlined. So when I add this, B is cancelled out and I get the value of 2H as 26 centimeters. Thereafter I can say the value of the hypotenuse here is 13 centimeters and the value of the base. So the value of the hypotenuse is 13 centimeters, perpendicular is 5 centimeters, and I know that 13 plus 12 gives me 25. So I can say that the value of the base here is how much? 12 centimeters. And we know in any case the length of the hypotenuse in a right angle triangle is the greatest among the three. Okay, now once you have these three values, sin P is So we are saying sine P, we are not saying sine R. So sine P, now if I have to calculate this, this and this, these are the three things that we are supposed to calculate. Okay, so what is the value of sine P? Sine P is base perpendicular upon the hypotenuse. So this comes out to be 12 by 13, right? Cos P, base upon hypotenuse. So this I can write it as 5 by 13, and we know that tan P is basically perpendicular upon base. So these are the three values that we were supposed to find out, and we have already found out. I hope you would have understood this. The best way here is, if you know this Pythagorean triplet, the Pythagorean triplet here is, if I know that one of the sides is P and the sum of the remaining two sides is 25. So I could have guessed that the Pythagorean triplet here is 5, 12 and 13. And then, so this kind of an approach is good for objective questions but not for subjective. The subjective question has to be solved like this one. Right? Let's move on to the last question, which is question number 11. So in question number 11, we need to state whether the questions are true. I mean, the questions, the answers that we are fetching to these questions are true or false, and then we need to justify our answer. So the first question says the value of tan A is always less than 1. Okay, for this it will be better if we just draw a triangle and then we see as to what happens. So now here I am taking a different orientation. So let's say if this is A, the angle, this is a right angle and this is C. So this becomes my perpendicular, this is my base and this is my hypotenuse. And let us say here I am talking about this is my angle A. And we know that tan A is equal to perpendicular upon base. So here the best way to approach this question here is, can I have, so let's say I want to make three cases here. What are the three cases here? Can I have the value of perpendicular equal to the base? Can the value of the perpendicular be greater than the base? Can the value of the perpendicular be lesser than the base? For this, you can just take an example. What is the example that you can take? So the first case that you can take here is, let us say that you are taking the perpendicular as 3 and the base as 4. Okay, here I'll take the perpendicular as 4 and the base as 3. Right? Now here this becomes your isosceles right angle triangle. We have done all such questions earlier also. So you can pick up all these examples from the first 10 questions that you have done. Okay, so here now when I say perpendicular is equal to base, in that case angle A is equal to angle C. So what are we saying? Here P by B becomes equal to 1. So let's say here I am saying P by B becomes equal to a 1 in this case. And here I can take a triangle. So one triangle wherein we are taking a triangle like 3, 4, 5 only. A Pythagoras triplet as 3, 4, 5. So we are taking the values of P, B, H. One case I am taking it as 3, 4, 5. The other case I am taking it as 4, 3, 5. Right, so in this case I have taken the perpendicular as 4 and the base as 3. In this case I am taking the perpendicular as 3 and the base as 4. Right, so now in this first case that I had taken, let's say this is the first case, second case and the third case. What is the value of tan A here? Tan A is 4 by 3. What is the value of tan A here? Tan A here is 1 and here the value of tan A is 3 by 4. And then we can talk about the negative values also, dependent on the quadrant in which it lies. For example, here it is, we are talking about this as an acute angle. If I talk about this as an obtuse or reflex angle, in that case these values they become negative. Right, so I mean the point that I am trying to make here is tan A can be 4 by 3, at the same time it can be minus 4 by 3, at the same time it can be minus 1, at the same time it can be minus 3 by 4 as well. So now this says the value of tan A is always less than 1. Less than 1, no, you have a value which is greater than 1 also, which is 4 by 3. So is this statement correct? No, you will say this is false. So you get one value which does not satisfy this statement. That means the statement has to be written as this statement is false. Correct? Let's move on to the second subpart. So in the second subpart, it is given that sec A is equal to 12 by 5 for some value of angle A, and we need to find out whether this is true or false, and we need to justify our answer. Okay, for this it is advisable that we draw a triangle, right? Let's say this is A, this is B, and this is C. Angle B is 90 degrees and angle A plus angle C is equal to 90 degrees. Okay, now we know that sec is the reciprocal for cos. So sec basically means what? Hypotenuse upon base. So in this case, hypotenuse is 12, base is 5, and the perpendicular length is not given to us. So what I am saying here is, let's say sec A we know is base upon hypotenuse, right? Is this correct when we say this? Because if sec A is equal to base upon hypotenuse, then what is the value of cos? So cos theta is base upon hypotenuse and sec is the reciprocal of that. So in that case, the value of sec A becomes hypotenuse upon base. Okay, so which is why we have taken the value of hypotenuse. Let's say this becomes 12x, this is 5x, and it is, you need to assume that x is a non-zero positive real number. Okay, this we have already assumed. Okay, so is this possible? The answer is yes, this is possible. Why? Because now in this case, can we find out the value of the perpendicular from here? Yes, we can, using the Pythagoras theorem. So is this true? Yes, it is true. So you'll give the answer here as true. This you could have done it without writing it also, but since we are doing such kind of a question for the very first time, which is why we have written it here. Okay, the next question I think fairly is easier. Cos A is the abbreviation for cosecant of angle A. No, cos A, the full form is cosine, not cosecant. Cosecant, the abbreviated form is cosec, not cos. Okay, next is cot of angle A is not the product of. So question number 3, false. Question number subpart 4, false again. Why? Because this is, you have to find out the trigonometric ratio of angle A. So you are finding out cotangent of angle A, which is not the product of cot and A. Okay, last we are talking about is sine theta is equal to 4 by 3 for some angle theta. For this also we need to understand with the help of a triangle. Now if I take a triangle and I know that sine theta is equal to a perpendicular upon a hypotenuse. Now, so without this also we could have done it, but just trying to understand this. In my earlier videos also we have talked about this, but I am talking about this once again because we are dealing with this question. So the question says sine theta is equal to this is 4 by 3, and here the value of the perpendicular here is 4x. Let's say the value of the hypotenuse here is, let's say 3x, and the base we can always find it out. But we know that such a triangle cannot exist. Why can't it exist? Because the hypotenuse in a right angle triangle, this is what we talked about in the earlier questions also, is the longest side among the three. So this hypotenuse is the largest side among all these three sides, and in this case you are getting the hypotenuse as a side which is shorter than the perpendicular, which is not possible. So which is why you will say that this is false. So as advised earlier also, please go through all these questions that we have talked about in this video, and if you feel that there is some problem, you can always revisit the questions, or you can put it in the comment section if you still have some problems. If you feel that today's session, this video has been really informative, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you start receiving updates from us regularly. If you want us to do some videos on some specific topics, please put it in the comment section so that we can do it for you. Thank you so much. Until next we meet, goodbye.